Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to solve polynomial equations of higher degree. The instructions are as follows. We're to express the given polynomial equation in factored form, then find all the roots. Okay, so for number one, let's say we have the polynomial equation 4x squared minus 9 equals 0. Okay, first task is to express this equation in factored form. Now, whenever you're factoring, step number one is to factor out the greatest common factor. So in both terms we have here, the greatest common factor is 1. Nothing else can be factored out. So we just leave it like that. Okay. Now, next thing is we want to see what factorization method or factoring approach we could use to factor this expression on the left. Okay, if you take a look at 4x squared and 9, what do you notice? You notice that these two terms are perfect squares and you have a minus in between it. Okay, so this is a difference of squares. So we're going to be using the different squares factorization method to factor this expression to the left of the equal sign. So the factoring formula for difference of squares, a squared minus b squared is a plus b times a minus b. Okay, the procedure is to simply root the first and the last term, and you express the roots as a sum and a difference. Remember, this factoring approach works for only the difference of squares, not the sum of squares. Okay? Alright, now so let's go ahead and factor this. To do that, we're going to take the square root of the first term and the last term, and then express the roots as a sum and a difference. Okay? So what do we have? The square root of 4x squared, the square root of 4 is 2, the square root of x squared is x, plus first, square root of 9 is 3, times, and then the same thing but difference this time, 2x minus 3 equals 0. Okay, so this right here is the factored form. This is one of the answers that we desire. Okay, let's write this down, factored form. Now the second part is to actually find all the roots. To find all the roots, we are going to have to set each factor to 0 using the zero product property. Okay, so we set 2x plus 3 equal to 0, and then 2x minus 3 equal to 0 also. Okay, now let's solve the first one. We can do this by subtracting 3 from both sides and dividing by 2. All right, let's go ahead and do that. Subtract 3. That yields 2x equals negative 3. And then we divide both sides by 2. Divide by 2, divide by 2. Our first root is negative 3 over 2. Okay. Second one, we add 3 and divide by 2. Add 3 to both sides. We have 2x is equal to positive 3. And then divide by 2. And our final answer, x, is equal to 3 over 2. Alright, so the roots or solutions to our polynomial equation is x equals, let's put them in set notation, negative 3 over 2 and 3 over 2. Okay? Alright, let's box it and move on to problem number 2. Alright, for number 2, what if we have the equation 16x to the third plus 54 equals 0. Okay, the first task is to express this equation in factored form. Step number 1 is to always inspect the terms you have and see if there's a greatest factor that can be factored out. In this case, you notice that 16 and 54 are both even numbers, so we know for certainty that 2 can be factored out. Okay, and it turns out here that the GCF is in fact 2. Okay, so we factor out 2 from both terms. We have 2 times 8x to the third. Remember, when you factor out the numbers as though you're dividing by that common factor. So we have 8x to the third plus 27 equals 0. Okay? Now we're going to shift our attention to the polynomial expression in the parentheses. Now what do you notice about 8x to the third and 27? They are cubes, okay? And since you have a sum in the center, we're going to be using the sum of cubes formula to factor this expression. All right, so what is the sum of cubes formula? Let's write that down real quick. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, remember that the first sign is always the same as the original expression. The second sign is going to be the opposite, and the last sign is always negative, always positive. Okay, so that's how you figure out the signs here. Okay, let's go ahead and apply the formula. So all you have to do is find a and b, substitute it into the formula, and then simplify where applicable. 8x to the third is a cubed plus 27 is b cubed. So to find a, we are going to set a cubed to the first term, which is 8x to the third. To get a isolated, we are going to do the inverse operation of cube, which is cube root. So you cube root both sides of the equation. Write that again. Cube root both sides of the equation, and we are going to get a is equal to 2x to just 2x. Remember, 2 times 2 times 2, or 2 cubed, is 8. So the cube root of 8 is 2. Okay, we have our a. Now let's get b. We're going to set up the equation b to the third equals 27. And to get b isolated, we will take the cube root of both sides, just as we did with the a. And we are going to arrive at the result b equals 3. Because 3 times 3 times 3, or 3 cubed, is equal to 27. Okay, so now we're going to write down the formula. This is the left side, so the factored form is a plus b times a squared minus ab plus b squared. Okay, now let's not forget the 2 that we factored out. Here we're going to bring that down. 2 times a plus b is 2x plus 3 times a squared is 2x squared. Let me change this to a bracket. So we have times a squared, which is 2x squared, minus a, 2x, times b, which is 3, plus b squared, which is 3 squared. Okay, so we found our a and b, we substituted into the formula. Now we're going to simplify where applicable. Okay, so we're going to have 2 times 2x plus 3, and then here we have 2x squared. Remember, when you're squaring this, since they're both in the parentheses, you're going to be squaring the 2 and the x, so we have 4x squared minus 2 times 3 is 6, 6x plus 9. Okay, let's not forget this is an equation which is equal to 0. Now the question is, can we factor 4x squared minus 6x plus 9? It looks like a perfect square trinomial, but one way we can know for certainty if this trinomial is factorable is by using our x game. Okay, so let's see if we can factor this polynomial or if it's prime. So AC goes on top, B goes on the bottom. AC is 36 and B is negative 6. Now, what are two numbers that multiply to give you 36 and add to give you 6? Let's see, let's make a chart and see if we can figure it out. So we have 36. 1 times 36 is 36. That doesn't work. What's the next number that goes into 36? 2 goes into 36 18 times. This gives us 20 or 16, nowhere near 6. 3 goes into 36 12 times. This gives us 15 or 9. That's not 6. Let's go on to 4. 4 times 9 is 36. This gives us 13 or 5. That doesn't work. 6 times 6 gives us 36. There is no way we can combine these two to get negative 6. So guess what? 4x squared minus 6x plus 9 is prime. Cannot be factored. Okay? So we're going to box this. This is our factored form. Now what we're going to do next is proceed to find the solutions or the roots of this polynomial equation that we had just factored. Okay, so to accomplish that, first thing we're going to do, let's rewrite the equation. We have a constant factored out there, so you want to be careful not to attempt to set that constant to 0. So anytime you have a constant factored out, you can divide both sides of the equation by that constant. So I can divide by 2 and divide by 2, so that constant drops off. The reason why I'm dividing by 2 and simplifying the equation is to make the problem solving process easier. Okay? If it's possible to reduce your polynomial equation, you always want to do that. Okay, now we're ready to apply the zero product property. So first we'll set the first quantity to 0 and the second quantity, the quadratic trinomial, to 0 also. The first one can easily be solved by subtracting 3 from both sides. So you have 2x equals negative 3 and dividing by 2. Okay, so divide by 2, divide by 2. So your result, x is equal to negative 3 over 2. Now let's shift our attention to this quadratic trinomial here. We have already determined that it's not factorable. So which other way can we solve it? We can solve this by using the quadratic formula. Okay? So in this case, a is 4, b is negative 6, and c is 9. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, all we'll do is substitute the value of abc into this quadratic equation, and then we'll just simplify from there. Okay, so we're going to have x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 4, times 9, which is c. And this entire expression here, we are going to divide by 2a, which is 2 times 4. Okay, all over 2 times 4. All right, let's go ahead and finish that up. So let me partition my workspace here. So let's see what we can do. Minus times minus is a plus, so x equals positive 6 plus or minus. When you square negative 6, remember the square affects the sign also. So it's not just negative 36, it's actually positive 36 because minus times minus is positive. Okay, so 36, 4 times 4 is 16 times 9 is 108, so minus 108. Okay, and that divided by quick correction, that's actually 144. So 4 times 4 times 9 is 144. Okay, and divided by 2a, 2 times 4 is 8. All right, let's go ahead and simplify further. We have x equals 6 plus or minus the square root of 36 minus 144 is negative 108, and that divided by 8. All right, let's go ahead and simplify this radical right here. Can do that on the side. So we want to simplify the radical piece here, the square root of negative 108. So let's do that on the side. Root negative 108. we're going to be extracting the perfect squares from 108 and taking their square roots, okay? First of all, you want to remember that the square root of negative is I. Square root of negative 1 is I, so the negative comes out as an I. Okay, let's decompose 108 into its prime factors. So if you take out 2, you're left with 54. Take out another 2, you're left with, let's see, 27. Take out 3, you're left with 9. Take out another 3, and you're left with 3. Okay, so now any factor that repeats itself, we have a perfect square situation there, and they can come out as the square root of that square. So 2 times 2 is 4. So these two, if you root 2 times 2, you get 2. Okay? And then 3 times 3 is 9. That's a perfect square. What's the square root of 3 times 3? 3. Okay, so we take the square root of these perfect squares. They're going to come out of the radical. 3 is by itself. It's not a perfect square, so it stays behind. Alright, so the square root of negative 108. Negative 108 is 2 times 3, which is 6. We're going to have 6. Let me write it again. Square root of negative 108 is 2 times 3 is 6. Don't forget the I, and then the 3 remaining behind. So it's 6I root 3. Okay? Alright, so let's apply that to this situation here. What I'm going to do is we're going to split up the fraction, okay? We're going to have 6 divided by 8 plus or minus this simplified form right here, 6I rad 3 over 8. Okay? If you simplify this by dividing by 2 top and bottom, you have 3 over 4 plus minus. Divide these by 2 top and bottom, you get 3I rad 3 over 4. Okay? So these are our roots right here. Let's write it together. So our roots are x equals, wiggly bracket, 3 over 4 minus 3I rad 3 over 4. That's the first one, and its conjugate 3 over 4 plus 3I rad 3 over 4. And the last one, negative 3 over 2. Okay? That's the only real roots that this polynomial equation has. So that's that for the roots of the second polynomial equation that we have. Alright, let's take a look at problem number 3. So for problem 3, we have the polynomial equation x to the third minus 9x squared plus 27x minus 27 equals 0. Okay? Alright, so let's see. Since we have 4 terms here, an initial method that you might want to apply here is factoring by grouping. But of course, before we do that, let's take a look at all 4 terms to see is there a greatest common factor that can be extracted. And the answer is no. Okay? So we can divvy it up and try factoring by grouping. So from the first 2, we can pull out an x squared. That's the GCF of the first 2 terms. So we're left with x minus 9. From the next 2 terms, we can factor out positive 27. And we're left with x minus 1 equals 0. Now, since the 2 quantities in the parentheses are different, factorization by grouping does not work here. Okay? So let's rewrite the original problem. We have to use a different approach to factor this expression. Now, if you take a look at this polynomial equation, if you inspect the first and last terms, x to the third and 27, what do you notice? You notice that they are cubes. So we can group them together and do what? Well, let's group them together first. X to the third minus 27, and you're left with negative 9x squared plus 27x. So we can factor these two using the difference of cubes formula. Okay, so let's set it up. We have a cubed minus b cubed. We're going to be using the difference of cubes formula. A cubed minus b cubed factors into a minus b. Remember the first sign is always the same, times a squared plus, the second sign is always opposite, ab, and the last one is always positive. Okay, so that's the formula we're going to use to factor the first two terms, the difference of cubes. All right. Okay, so let's go ahead and factor this. So we're going to have a minus b is x. Well, let's figure out a and b first, okay? So we're going to do that. We have a cubed, and this problem is x to the third. So to get a, we take the cube root as we did in the other example, and that yields the value a is equal to x. All right, and then to get b, we're going to set b cubed to 27. Remember, you don't take the sign, okay? Just take the numbers, the terms, and then you should be fine. Take the cube root of both terms, and then you have what? You have b is equal to 3. Now, these are the a and b terms I will substitute into this formula to get the factored form of my first two terms. Okay, let's write down the formula again so that we don't make mistakes. A minus b times a squared plus ab plus b squared. Okay, so let's apply it. So we have a minus b is going to be x minus 3. A squared is x squared plus ab. ab is x times 3, which can be written as 3x, plus b squared, 3 squared, which is just 9. Now let's take a look at the next two terms in this polynomial equation. What can we factor from these two terms? What is the GCF? The GCF is negative 9x. Okay? So if we factor out negative 9x from these two terms, what do we have left? We have x minus 3. Okay? X minus 3 equals 0. Now this is great because these two quantities in the parentheses are identical, so we can factor them out. So if we factor out x minus 3, factor out x and x minus 3 from both sides, we have x minus 3 quantity times, and we're left with x squared plus 3x plus 9 minus 9x. Okay, so that equals to 0. Now if you take a look at the second quantity here, we can combine 3x and, we can combine positive 3x and negative 9x. So we're going to have x minus 3 times x squared minus 6x plus 9. Okay, equals 0. Now, take a look at this quadratic trinomial. Can it be factored? That's the question. If you take a close look at it, if you double the square root of the first and the last term, and you get the middle term, then this is a perfect square trinomial. Okay? Let's see if that's the case here. If I double the square root of x squared and 9, what do I get? I get 2 times x times 3, 6x, that's the middle term. So this is a perfect square trinomial. So since it is a perfect square trinomial, I can use a special case factoring approach here, a shortcut. I'll just take the square root of the first and the last term and bring down the middle sign. Okay, so the factored form will be x minus 3 quantity squared equals 0. A different way of doing this will be to use your x gain, and then it works perfectly too. You just have x minus 3 twice. Okay, let me just show that to you. So you make a nice little x. AC goes on top, which is 9. B is negative 6. What two numbers multiply to give you positive 9? And now to give you negative 6. Negative 3 and negative 3. Okay, so you have x minus 3 twice. which is x minus 3 quantity squared. Now this is the factored form. This is our first answer right here. Oh wait, we can even let's dress it up a little bit. These are identical, so we basically have x minus 3 times x minus 3 times x minus 3 equals 0, or you can write it as x minus 3 quantity to the third equals 0. Okay, those are the factored forms of the original polynomial equation. Okay, let's go ahead and solve it. That's the second part. So since we have three identical factors, we just extract one of them, set it equal to 0. Now to solve this, we just add 3 to both sides. So we have x equals 3 with a multiplicity of 3 because we have it occurring 3 times in its factored form. Okay, so there goes the solutions to the polynomial. All right, let's go ahead and take a look at problem number 4. So for problem 4, what if we have the polynomial equation x to the 4th plus 3x squared minus 9x squared minus 27 equals 0. Okay, so the first task is to express this in factored form. So you might want to resist the urge to combine these two terms in the middle because it might complicate the factorization process. Okay, now since we have 4 terms, the first logical approach will be to try and factor by grouping, and let's hope that works here. Okay, so we divvy down the center in front of the sign, and we go ahead and find the GCF. So x to the 4th and 3x squared, the GCF is x squared, and we're left with x squared plus 3 after dividing these two terms by the GCF. If we extract the GCF from these two terms to the right of the partition, our GCF is negative 9, and we'll be left with x squared plus 3. Okay, remember minus divided by minus is plus. This is excellent because our quantities in the parentheses are identical. Okay, so what we'll do is we'll proceed to factor out these two common quantities. We have x squared plus 3, and then we're left with x squared minus 9. Let's group that together. X squared minus 9 equals 0. Now, can any of these quantities be factored any further? The answer is yes. The difference of squares can be factored. Remember the difference of squares formula we talked about earlier? A squared minus b squared is what? A squared minus b squared is a plus b times a minus b. Remember, this is not the Pythagorean theorem. A lot of students get this confused. A squared plus b squared equals c squared. That's not what we're doing here. Okay, this is something entirely different. We have a difference of squares. This is the factored state. Okay, so we're going to apply that here. Remember the procedure. Just root the first and the last, and then you express them as a sum and a difference. All right, let's go ahead and do that. Take the square root, and then you have the sum and the difference. So our factored state will be x squared plus 3 times x minus 3 times x plus 3 equals 0. Now this is the final factored form of the polynomial equation. Now the first term here, the first factor, x squared plus 3, not only is this not a perfect square, but you have a plus, so we can factor that. Okay, so let's write it down, factored form. Okay, to finish this problem off, we are going to proceed to use the zero product property to set each factor equal to 0 and solve for the solutions of the polynomial equation. So we have x squared plus 3 equals 0, x minus 3 equals 0, and x plus 3 equals 0. To solve the first one, we're going to isolate the square, subtract 3 from both sides, and we'll use the square root property, okay? So we have x squared equals negative 3, and then we go ahead and take the square root of both sides, and that gives us x equals plus or minus, now the square root of negative, remember the square root of negative 1 is I rad 3. Okay, so those are the first two roots, and then here just simply add 3 to both sides, x equals 3, and then here you subtract 3 from both sides, x equals negative 3. Okay, so our roots or the solutions to the polynomial equation is we have negative root 3i, positive root 3i, negative 3, and positive 3. Okay, so there goes the roots of the polynomial equation. All right, let's go ahead and take a look at problem number 5. So for problem 5, we have x to the 4th minus 81 equals 0. Task number 1 is to express this in its factored state. Okay, now what do you notice in x to the 4th and 81? Well, it's obvious that 81 is a perfect square because 9 times 9 is 81. But how about x to the 4th? Now you have to note that a variable, let's say x raised to an even power, is what? Is a perfect square. Why is that? Because you can evenly divide the power by 2. Okay? So just keep that in mind. Alright? Any variable with an even power is a perfect square. So if this is a square and that's a square, this is a difference of squares. So we can use the difference of squares formula, a squared minus b squared equals what? A plus b times a minus b. Alright? So take the square root of the first and the last, and then express the roots as a sum and difference, as we've done in previous problems. So we have x squared plus 9 times x squared minus 9 equals 0. Now, can we factor this further? The answer is yes. Now, which of these two can I factor further? The difference of squares. This cannot be factored, okay? So we'll look at this again. We're going to take the square root of the first and the last, and then write down the sum and the difference of the roots. So we're going to have x squared plus 9, and then we're going to have x plus 3 times x minus 3. Now, this is the factored state of the original polynomial equation. Okay, so this is the factored form. Okay, so to finish this up, we're going to find a solution by using the zero product property. We set each factor to 0, and then we go ahead and solve for x. The first one, we're going to have to use the squared property since we can factor this. Subtract 9 from both sides. That yields x squared equals negative 9. And then take the square root of both sides. And we have x equals plus or minus. Remember, the negative underneath the square root comes out as an I, so it equals 3. Square root of 9 is 3, and then the square root of negative is I. Alright? Okay, over here, subtract 3 from both sides. X equals negative 3. And then over here, you add 3 to both sides. X equals 3. So our roots, or the solutions to the polynomial equation, are negative 3i, positive 3i, negative 3, and 3. Okay, so that's the answer for problem number 5. Okay, let's go ahead and take a look at number 6. So for number 6, let's say we have the polynomial equation 3x to the fifth minus 7x to the third minus 6x equals 0. Okay, so first task is to write this in as factored form. So if you look at these three terms, what do you notice? There is a GCF that can be factored out. Do you see what the GCF is? It is x. Okay, so if you factor out x, you're left with 3x to the fourth minus 7x squared minus 6 equals 0. Okay, now the quantity in the parentheses is a trinomial of the fourth degree. So how can we factor that? Whenever you have trinomials, you always want to use the x gain to express it as a polynomial in 4 degrees so you can factor by grouping. Okay, so AC in this situation is 3 times negative 6, which is negative 18, and B is negative 7. Now, what two numbers multiply to give you 18 and add negative 18 and add to give you 7? Think about 9 and 2. Any variation of this? Which variation of this works? Since the sum is negative, the bigger has to be negative. Okay, so nice. So this should work. Okay, so now we have x times 3x to the fourth. I'm going to replace the middle term with these two values here. Minus 9x squared plus 2x squared minus 6. Now I can factor by grouping. Okay, so I divvy down the center. Bring down the x. Okay, from the first two, I can pull out a GCF of what? I can pull out 3x squared. Okay, pull out 3x squared. Then we are left with x squared minus, take out 3 from that, minus 3. Okay, now over here we can pull out a 2, so plus 2, and then we have x squared minus 3. And then let's check to see if our factorization is correct. You notice that these two quantities in the parentheses are identical, which is excellent, which means that our factorization is going well. So bring down the x. The x squared minus 3 and the x squared minus 3 are common factors, algebraic factors, so we factor them out, x squared minus 3, and then we're left with 3x squared plus 2. Okay, let's not forget everything here is equal to 0. So we have 3x squared plus 2. Okay, now can this be factored anymore? The answer is no. This is the factored state. So we have x times x squared minus 3 times 3x squared plus 2 equals 0. Okay, so this is the first result that we want, the factored form with integer coefficients. So this is the factored form. Okay, so lastly, we're going to go ahead and set each factor to 0, and then we'll solve that algebraically, okay? So applying the zero product property, we set x to 0, each factor, x squared minus 3 to 0, and 3x squared plus 2 to 0 also. The first one is already solved, so let's shift our attention to the second one. Add 3 to both sides. X squared is equal to 3. And then we'll take the square root of both sides to get rid of the square. And then we have x equals plus or minus the square root of 3. Okay? Alright, let's shift our attention to the last factor. You subtract 2 from both sides. That leaves you with 3x squared equals negative 2. Divide both sides by 3. And that yields x squared equals negative 2 over 3. And then lastly, you take the square root of both sides. Okay? take the square root of both sides, you're going to have x equals plus or minus. Now, since you have a minus out of the square root, you have an I root 2 over 3. Okay, this can be simplified further, but we'll just leave it like this in this problem. Okay, so let's go ahead and write down what our roots are. So our roots are x equals, squiggly brackets, we have negative root, yeah, we can write it like that, negative root 2 over 3i, positive root 2 over 3i, negative root 3, 0, and root 3. Okay, we have 1, 2, 3, 4, 5 roots in this problem. Okay, so there goes here the second set of answers for problem number 6. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. Do not forget to subscribe to our channel for updates to other great math tutorials such as this. If you have any questions on any of the problems that we did, or the factorization or solving of polynomial equations in general, just place your questions in the comment section below, and we'll be glad to address it as soon as possible. More quizzes can be found on math.serve.com. Thanks again for watching, and have a wonderful day.